Hi guys, here we go. We are about to graph a piecewise function. Now, this one's kind of easy because one graph is ending at 0 and the other one's starting at 0, which is, your y-axis. Essentially, when x is 0, you're at your y-axis, and people feel like it's the middle, and it's a nice place for people to know what they're doing, kind of calibrate yourselves at the origin a lot of the time. But the reality is it doesn't have to be 0. It could be at 1, at 2, at 3, at a negative number, whatever. So try to keep that in mind while we do this, in case the next time you have to do an example like this, it's not 0. All right. So what are piecewise functions? Well, piecewise functions are basically asking you to pass the baton in a relay race. So x squared is going to run the race. When is x squared running the race? Well, if it were on a number line, x squared would be running the race only for the time that x is less than 0. So up until there. And then they're going to pass the baton, or try to pass the baton, to 2x minus 4. And when is 2x minus 4 running the race? Well, 2x minus 4 is running the race from 0, like starting at 0, until positive infinity. So this area, 0, is your, you can't see that, can you? 0 is another way of saying the y-axis, right? Sorry. Okay. So let's do a couple other things. That's inequality notation. Inequality. Think about the word. I mean, it's not an equation. It's unequal, hence the name. Inequality. Interval notation is another way we can write the interval. I like it better because it makes more sense to me from left to right. I have a video explaining interval notation that I'll attach in the thumbnails at the end of the video if you need support with that. So definitely go there, okay? So there we go. Now, let's just point out a couple other things. Another thing we can look at is x squared, right, is only when x is less than 0, or interval notation, negative infinity till 0, not including 0, but x squared is only going to live in this territory. This is the only place it's allowed to be. So does all of x squared normally fit there? No. Hopefully we know x squared is a parabola, right? And it's something like this, and normally it would dip into this right-hand side. However, we won't draw that. It's almost like bloop, cover it up, or dry erase, or when you put, it's like when you're painting something and you use the painting tape and you're doing the little hack where you paint it over your white wall, you put the blue painter tape up, you first go over it with either a clear, like a gesso, or the same as the wall, seal the tape, that's the trick, and then you go in with the other color that you're trying to do, peel that tape off, crisp line, nice, right? So it's kind of like that, like you have your parabola, but you put tape up, right? And you're going to peel the tape, and you're like, ooh, no mess on the other side. And then this one, 2x minus 4, right? Well, that one is going to only live when x is greater than or equal to 0. Because it could be equal to 0, I'm going to make sure I draw a dramatic, solid line to clarify, like, okay, 0 is included, and then it's going to live in this territory here. Now, normally, if it was just plain old 2x minus 4, would it be limited to this area? No. It would not, right? It would be a line. Y-intercept is -4. Slope is 2. You have a whole line. But a piecewise will say, no. You have this from here to here. You have that from there to there. Follow the rules. Everybody knows the rules. So, x squared. No transformations, parent function. The vertex would be at the origin. However, use pencil if you rush to drawing things. It's going to have an open circle. I'm going to be very dramatic of how big things are because it's only less than 0. And then, if you've watched my videos and listened to me explain my tricks for drawing x squared, you should know over 1 up 1, over 1 up 3. This is only when it's a 1 in front of the x squared. Over 1 up 5. If you have the space, over 1 up 7. Over 1 up 9. Over 1 up 11. And so on. Done. Finished. The rest of this, not getting drawn. Beautiful. From here, green's taken over. 2x, just going to trace over it. Minus 4. 1, 2, 3, 4, negative 4. It's greater than or equal to 0. So negative 4 is right there. That's the negative 4. Slope is 2. Now, if the slope is positive 2, that means don't put on like horse blinders, like where you can only see like a limited amount of space, like a spotlight. You got to back up, okay? Positive lines go that way. What happens all the time? People know they have a positive slope and say it's going this way. It's the left. They'll go up. Does that make sense? The answer is no. It does not make sense. Because then you have a line going down like that. And a linear equation like this has a negative slope. Think about it. Up 2 over 1, up 2 or 1. And I'm going to make lots of dots. Lots of dots. Beautiful. And it should be straight because lines are straight. That's it. Done. If you're going to take a calc class one day, you're probably going to need to know what's going on with piecewise functions because you're going to take limits quite a bit. So anyone that wants to know anything about a limit, if you pop it in here, so it says to you, what's the limit as x approaches 0 of, let's call this f of x instead of f of x. So if you approach 0 from both sides, the limit is asking you what y value are you approaching. It should be the same. It is not. So this answer is does not exist. However, if someone asks you what is the limit as x approaches 0 and they give you this little minus sign, that means from the left only of f of x. What is that? What y value does it look like we're approaching? You don't have to get there. Limit, what does it look like you're going toward? 0. And then limit as x approaches 0 with a little plus sign. Context clues, could you figure that out? Or deductive reasoning. From the right. What y value? Negative 4. That was a little bonus for anybody living in the calculus world. And that's the end of graphing this. In the next video, we are going to evaluate a piecewise function. And like I said, if you need more help with interval notation or other piecewise stuff, see what I have in the thumbnails at the end here. Thumbs up if you're happy and you know it. Thumbs down if you're not. Hope you feel smarter. Bye.